Okay, we're going to do a little experiment here with our two solutions, 0 parts per thousand and 100 parts per thousand. The 0 parts per thousand, which has the density of 1, we put our little floaty in here, and if you come up close you can see that the density of the block is less than the water, therefore it is floating, and it's in line with that top dark line there. But if I take this out, I could almost predict that I haven't changed the density of the block, but now I've got my 100 parts per thousand solution, which is a lot denser. It should, if I'm right, float higher. And if you come closer, you can see that in actual fact it's sitting such that it's even, the water level's even below that bottom line, so it's sitting higher in the water. If we can capture this idea that the denser the solution, the more something's going to float, and put that into a tool or instrument, we can make something that will give us a relative density, which will then be able to be related back to salinity. Let's go make our tool. Here's my test solution. I'm going to just put that in one of those cut off 1.5 litre containers. I've dyed it blue so it's a little easier to see. Just put that aside. I've got a straw here. First one I'll make is use the surf wax. It's pretty straightforward. I'm just going to make a tiny little ball of surf wax and push it in the end. If it's one of these extending straws, put the extender part on the bottom. We need to block this off. We don't want water getting in it. And we want a nice firm fit for our screw. This screw, I've weighed this screw, it's about 2 grams, and I'm screwing it into that ski wax. And then I just want to seal that off. So a little bit more wax over that. Now the trick is to get the right amount of weight. Because too heavy and it'll sink too deeply, and too light and it will topple over. We want a wee bit of weight on the bottom, and we want the straw to be sealed because we want it to have buoyancy. So bring back our test solution, see how this is going to go. There we are, that's good. It's floating straight up and down. So we would expect that to have a fixed density and float at a certain level in this fresh water and a different level in a more dense solution. The other way to do it, if you haven't got any surf wax, just be careful with this one of course, is a little bit of candle wax. So make sure you don't do this near a fire alarm. So we're just going to get the wax to melt, and we just want to melt some wax straight down into the end of that. So the straw, so we're again going to block that off, but we want most of it to be at this end here. Put a bit of wax on our nail. This is the nail we're going to put into the end here. Again, between 2 and 3 grams, not too heavy but not too light. Flathead nail's best, so it sort of can seal off the end a bit better. And keep that burning, you might need that in a minute. Put that in the end, a bit more wax over it while it's still fresh. Melt that wax a bit, put that in, a bit more wax. Bit trickier than the ski wax, but as long as we get this seal and a bit of weight on the bottom here, there we go. And now we just drip a bit of wax around that bottom there. Now how much wax you put on, you might have to change that a little bit as you go, depending on what sort of weight we've got here and what weight we need. We'll just give that a wee test. Yep, it's working fine. We've got a good bit of buoyancy there, and it's not hitting the bottom, pretty much straight up and down. The next thing is to set a scale. Now the scale, of course, is going to depend on what it says for pure water, fresh water, and using a ruler and a very, very sharp pencil, use the millimetre scales. You might get someone in your household who's really accurate and neat and tidy to do this, and very precise, and also can see pretty sharply and clearly. And we're just going to mark up a wee scale as best we can with those millimetre lines. Now make every third one or every fifth one longer so you can sort of distinguish it, and then get your scissors and cut a strip. I've already finished one over here and I can show you. So here we've got the scale, the piece of paper in here. Now the usefulness of the piece of paper is that once you've got your scale marked, you get roughly where that piece of paper is going to be and mark there. Take that out, take the paper out, mark that piece there 1, because density of 1 here, or in this case, we'll look at this later, specific gravity of 1. And then once you put it back in the water, you can slide the paper up and down to exactly have that 1 reading at the meniscus of fresh water. And then we have set our tool and standardized it against a known density, pure water. And as pure water is the reference density for specific gravity, then we have made an instrument that will measure specific gravity.